All right, so now we want to talk about the decision to borrow. So why does someone borrow money? Well, they borrow money because they want to have money now in order to spend it on something rather than have it later when they're going to have to pay the money back. So we're going to look at a little model that is very simple because we're just looking at consumption now versus consumption later, right? Um, that makes a certain amount of sense. If you borrow money to go to school, you're going to have to pay it back later. If you borrow money to buy a house, you're going to have to pay it back later. And the general reason to borrow money is that you're going to have more money later with which you can pay it back, right? And so in this case, we think, all right, Julia's going to have $100 later. So she can consume nothing now and consume $100 later. Of course, depending on when now and later are, if you don't consume anything, you might end up dead. So that doesn't really work that well. So Julia's going to want to borrow. So how do we know what she's going to borrow? Well, unless she's borrowing from her parents, she's not going to be able to borrow the full $100. And the reason for that is that she's going to have to pay interest. Now, the interest rate is what a borrower pays or what a lender receives in order to borrow and lend. So in this case, if Julia faces an interest rate of 10%, then she can borrow about $91, right? And then she would have to pay $9 in interest. That's about 10% of 91, and the original $91 back. And so then she would be able to pay $100. So she could borrow the whole $91 right now and pay it back in the second period. She could borrow at a different rate, right? She could borrow $70, in which case she would have to pay that back with interest, and she would have $23 left because 10% of 70 is $7. 100 minus 70 plus 7, or 77, is 23. She could borrow just $30 today, right? In which case she would have to pay back $33 in the future, leaving her with $67. And so we're going to see that this actually creates a straight line with a slope that is equal to the interest rate, and that gives us our feasible frontier, right? So it's actually 1 plus the interest rate is the slope. And so she could choose any point along the feasible frontier. We can think of this as the marginal rate of transformation of turning a dollar now into a dollar tomorrow, or vice versa. So there's our feasible set, and the idea is that she doesn't necessarily want to be at this point where she would have $100 in the future and no dollars today, because she wants to consume something today. That makes a certain amount of sense. And so she can, by borrowing, move down her feasible frontier. Oops. Now, if the interest rate is much higher, for example, if the interest rate is 78%, then she's not going to be able to borrow as much because she won't be able to pay it back, right? So the maximum amount she could borrow today, if the interest rate is 78%, is $56. And so you can see that her feasible frontier shrinks when the interest rate goes up. Now you might be thinking, 78% interest rate, that's crazy, that's really high. And it is really high, but it is not at all crazy. Interest rates can be that high or even much higher depending on the type of institution that's lending. You know, in a modern industrial economy like the United States or Western Europe, lending through banks is going to be the sort of the safest and lowest interest rate that you can get. But borrowing at payday lenders, borrowing from loan sharks, borrowing from informal lenders, they're going to come with much higher interest rates. So the way we want to think about it is that 1 plus the interest rate is the trade-off between what you can consume now and what you can consume in the future, right? Where the interest rate equals little r, right? We'll call that r. And so as the interest rate r goes up, the slope gets steeper, 1 plus r, and our feasible frontier shrinks. So how are we going to decide where we want to be? Well, it shouldn't be a surprise by now, right? We're going to set the marginal rate of transformation, the slope of the indifference of the feasible frontier, equal to the marginal rate of substitution, which is going to be the slope of some indifference curve. So in this case, we have an indifference curve, and she would be indifferent between consuming a lot now and a little bit tomorrow, or a little bit today and a lot tomorrow, right? Or next year, or in 10 years, or whenever the loan has to be paid back. Now, is this the best she can do? Clearly, it's not the best she can do because we know that indifference curves utility or satisfaction is increasing as we move away from the origin. And so there's going to be some place where she can do better, right? The slope of her indifference curve, the marginal rate of substitution, is too flat at point E and too steep at point C. She would rather be at some place between them. And so that's going to be a point like point F, right? That's the highest utility she can get, where the slope of her indifference curve, the marginal rate of substitution, is equal to the slope of her borrowing constraint, or the marginal rate of transformation. So we can see this, now, right? The slope, remember, if we were doing calculus, the slope would just be the derivative of the indifference curve, but we can just look at the difference between one unit and get an estimate, a pretty good estimate of the slope of the indifference curve. So in this case, the rise is $1.50, and the run, 49 to 50, is just $1, so it's just 1.5 over 1, or 1.5. So where that's going to be, she's going to want to set the slope of her indifference curve equal to the slope of the feasible frontier, which is going to be 1.1 if she's borrowing at 10%. So that's going to be here at point E, where she's consuming 58 now and 36 tomorrow. We know that she wouldn't want to consume up here at point F, right, because she could do better. The slope of her indifference curve, the marginal rate of substitution, is much steeper than the slope of the marginal rate of transformation. Now, unfortunately, if she's facing a much higher interest rate, then her feasible frontier shrinks. That means she's going to face a different trade-off, and she's going to choose to consume at a different point because she's going to have some lower level of utility. Right here at point G. So she's going to consume at 35 today and 38 tomorrow. The idea here is that the trade-off is worse for her with the higher interest rate. And so she consumes about the same in the future, 38 versus 36, but she consumes much less today because of that higher interest rate. She's not as willing to borrow now. So how do we decide how much people are going to borrow? Well, there's going to be some level of impatience, right? Now, when we say impatience, it might not, like we think of impatience as a bad thing. It might not necessarily be a bad thing. It might be that you're impatient because you have no food to eat. If you have no food to eat, you should be impatient. You should be willing to borrow at a high interest rate in order to feed yourself and survive into the future. It could also be sort of just regular impatience. Oh, that person's impatient. They just want to consume now. So we're going to have some measure of this impatience. Just keep in mind it's not necessarily a bad thing. What we're going to call the discount rate, which is rho, which is this little p over here. It's a Greek letter rho. It looks like a p. So that's going to affect our borrowing decisions, right? And the idea is that consumers will prefer to smooth their consumption depending on how impatient they are. So if they're very impatient, they'll want to bring more consumption to today. If they're less impatient, they're willing to put off more consumption until tomorrow. But overall, they're going to want to consume. They're not going to want to consume nothing today and a lot tomorrow, or a lot today and nothing tomorrow. So the optimal decision here, when we're thinking about borrowing, is that we can set the marginal rate of transformation, which we know is 1 plus the interest rate, equal to 1 plus the discount rate. So that just gives us a nice sort of easy, quick formula to say, all right, the measure of the slope of the indifference curve is just 1 plus rho. And that could change depending on where we are, but it's a nice, easy thing to remember. All right, we'll stop there, and we'll pick up the other side of the coin, because if someone is borrowing money, then someone also must be lending money, and so that's going to be Marco in our